Welcome to this quantum security and defense presentation, automated packaging for photonic quantum systems, and thank you for being a valued member of our community. Dr. Erik Beckert received a diploma in precision engineering in 1997 and a PhD in optoelectric system integration in 2005, both from Technical University of Ilmenau, Germany. Since 2001, he works at Fraunhofer Institute for Applied Optics and Precision Engineering, IOF, in Jena, Germany. There he is the head of the department Optomechatronical Components and Systems since 2020. Erik Beckert also co-founded the company's Quantum Optics Jena GmbH and Photonics Foundry GmbH, and is a part-time business developer for Swedish fiber equipment manufacturer Nyfors Technology AB.
Okay, thank you. I hope you can see the slides. Okay, very good. I quickly added the German flag to make sure that everybody knows that we are from Germany. And I will talk about automated packaging for photonic quantum systems. I'm pretty sure that I'm not the one that has to tell you that there is a huge opportunity in quantum technologies. Everybody of us knows that quantum is a growing market, computing, communication, sensing, and so on. You can find a lot of nice market presentations in the web, how nice the quantum future will actually look like. But for us, as we are photonics people, the good news is that a lot of quantum technologies has to deal with photonics. Not only photonics, but a lot of photonics is going around in quantum technologies, since it's not only a fact that photons are kind of a particle that can have quantum properties, so you can use and manipulate them, but also classical photonical light you can use in quantum technology. I would like to emphasize also as an example on quantum computing. So it's a good thing that the previous talk was about algorithms using quantum computers. But if we take quantum computing as an example for quantum technologies, then you will find, okay, there are different types of architectures that have something to do with photonics. There's classical photonic quantum computing on the very right, but other technology or architectures like neutral vacancy, nitrogen vacancy centers, or atom traps or ion traps. There you also use photonics. You use lasers to illuminate these particles with their quantum properties, or to read out or to manipulate the quantum properties of these particles. So it's good news that photonics has a lot to do with quantum things, and this is, let's say, this goes into the direction of the general challenge that our customers has. Customers of our company, the Photonics Foundry company. Our customers want to launch products for classical light, lasers, but also for quantum technologies. They have a product idea. They have a long time to market. They don't have the stuff. They don't have the infrastructure and the people to realize their products. You see classical products on the right side that can also be used in quantum technologies like laser to illuminate quantum particle. So this is something that our customers experience as a challenge. And that is actually what the Photonics Foundry is about. What we want to do, we want to offer a service to realize photonic systems for classical light, but also for quantum technologies. And what does it mean that we offer a service? We offer, let's say, as a side effect, we design the systems of our customers for manufacturability, but our main service is to prototype the products of our customers, to make a small and medium volume production for our customers until they are able to manufacture their products on their own, or eventually they also want to work fabless and they want to continue producing their products on our facilities. Last but not least, if the customer wants to manufacture the product themselves, we can also transfer the technology, the equipment, and the processes to the facility of our customers. This is our business model at Photonics Foundry, Photonics assembly as a service for our customer. We founded the company something like 2 years ago. You see the 3 founders and myself, also amongst these people. My main affiliation, also for Catania, to make sure my main affiliation is still Fraunhofer, but I'm a part-time business and innovation manager at the company Photonics Foundry. We have quite a long and outstanding experience in the field of photonics. As you know, we are based in Germany, in the northern part of Germany, in the town of Bremen. That is also well known to Anna. Lots of space business is going on in Bremen. Also, we have a seed funder, the company Microfab, that comes from microsystems manufacturing. And what we actually really can offer as an infrastructure of our company is we have the rooms, clean room, and lab room, and we have the equipment, precise photonics assembly equipment to manufacture the products of our customers. So far for the general idea of Photonics Foundry. Of course, when we assemble photonic systems, we talk about classical hybrid systems like lens alignment, mirror alignment, different type of component alignment. But I later will come back also to the fact that more and more photonics is also going into photonic integrated systems. And we will also see that on behalf of quantum computing architectures, for instance, photonic quantum computers. So also photonic integrated circuit packaging, PIC packaging, is a big part of the service portfolio that Photonic Foundry provides. Even the testing of photonic integrated circuits is part of our portfolio. But what does it make now special for quantum technology? I mean, we already talked about that photonics, photons have good use in quantum technology, quantum technologies, but this really relates that on one hand, we talk about really single photons, so this individual particles, the photons that can have quantum properties and that can be created, manipulated, and read out regarding such quantum properties of photons. Then, of course, it becomes interesting that people want to create such special kind of photons in entangled photon sources, in single photon sources. They want to store such photons in quantum memories eventually. But I already told you also classical laser light can be used or is of use in quantum technology. I will provide you an example in a few minutes about that. So good news is that photons, you have to deal with classical light, but you also have to deal with single photon properties. And this is actually a specialty that a photonic packaging company has to consider and has to address when we want to deal with customers from the quantum world. Since what does it mean with respect to packaging when you deal with properties of single photons, but in general also classical light for quantum technology? You have to take specific care of component selection, low loss components, low loss coatings for optical components. Very often, high accuracy and stability of the accuracy is in particular relevant for quantum system. The interface requirement, so light photons are traveling from one system to the other. You shall not use lose the photon at such interfaces. So low loss interfaces are a big topic in quantum technology. And last but not least, you also have to know about, in particular, the properties of single photons. You have to measure single photons. You have to create low noise measurement systems. You have to use low noise measurement system. Very often you want to control them in a very fast way. So high frequency, gigahertz frequency electronics are very often involved. You have to deal with the properties of single photons. You have to tag the time when they arrive. You have to correlate the time with other photons. So tagging and correlation of photons is a big topic that you have to be able to work with. And last but not least, the big trend, scalability, really goes in photonics from a bulk photonical system to photonic integrated system. You see typical examples for such an evolutionary roadmap here on the right side of the slide. On the top, there is a bulk optical photon, entangled photon source that I realized at Fraunhofer 10 years ago. It's a quite old picture. In the midst, you see more integrated micro-optical setups, in this case from the Ferdinand Braun Institute in Germany. And on the bottom of the page, you see that people try to integrate all the functionality that they need for computing, for communication on the chip. So photon people try to do the same as the microelectronics people. They try to integrate every functionality on the chip. This is, of course, how people would like to address scalability of photonic or of quantum system.
You can join the QSEC Dev community to watch the full version of this and over 80 other lectures on quantum technologies, attend events, receive free training, and more. QSEC Dev is a users community working to forward quantum secure communications. The community is represented by Quantum Security and Defense that provides supply chain orchestration and consulting services on behalf of our members. Find out more. Google quantumsecuritydefense.com today.